get the clarity what we are going to discuss. Right, coming to the syllabus now. As per my knowledge, the first unit we completed this third unit first off, except triggers, correct? Is it right?
Yes, sir.
Yeah. Now, as I told, the triggers are there in the laboratory, that is 12th experiment. So that along with the laboratory, we will discuss this topic. Don't worry about that. It is a practical oriented thing. Okay? Is it okay? Hello? All of you, is it okay?
Yes, sir.
Yeah. Now we are going to start with second half of the third unit, the schema refinement. So this is very, very important of our database management system. Actually, the database management system is implemented because of this topic, because here this topic contains normal forms. Here normal forms. Because of this normal forms only, we are implementing databases. So that without this normal form, we cannot have any database. If you remove the normal forms, that is again is a file management system. So that we need to learn and we need to understand these normal forms. So before discussing of the normal form, here how it is required, what it is required, when should we apply, where should we apply. For applying of this normal form, what you need to learn and what are the parameters you have to consider. All these things we have to learn in this schema refinement. It is very important. Well, if you go anywhere, if they are going to ask any question from the database, the first question comes from this topic only, because it is a fundamental mechanism for the database management system. That is a normal forms. Is this clear, everyone? So that please everyone follow and attend and observe and practice how we are going to apply. If you are having any doubt or any clarification, please ask us, ask me immediately, I will explain. Okay, because this is very, very important. Are you clear? Are you clear? Right. Now, coming to schema refinement. Here, what is the meaning of refinement? Can anyone tell me English meaning? Any one of you? What is the meaning of refinement? Hello, I'm asking very simple synonym of refinement. Even you can search in the Google also. What is the meaning of refinement? I think all are from English background. Hello? Hello? Any one of you please respond. What is the meaning of refinement? I'm not getting any response from you. I don't want to ask individually. Please tell me, anyone. What is the meaning of refinement?
Removing unwanted materials or data from.
Can you repeat, Abhilash? I'm asking English meaning only. English
Yes,
meaning.
removing English meaning. So removing anything from a particular thing. In our technical terms, removing unwanted data from some database.
Refinement. The process of removing impurities or unwanted elements from the substances. 100% right, whatever Abhilash mentioned. Simple. Means refinement. Just we have to remove and add whatever the things are required. Yeah, that is what exactly the refinement of schema, the first topic here in this third set of schema refinement. Then what is the meaning of schema here in our database? What is the meaning of schema in our database? Hello? What is the meaning of schema?
The high level data.
Yeah, high level data. For example, you are prepared one table. You're like this. It contains 5 attributes and 4 tuples. Now you know this is our ticket number, this is name, this is gender, this is GPA, and this is maybe what can I tell? Age. So what is the high level data here? You are filling some blah 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 some information here. What is the high level data here? Schema. What is the schema here? Hello.
Hall ticket number, name, and all that.
These attributes are, this is a column names or attributes names are schema. So I told you many times this, and this is instance. Correct? Is it right?
Yes, sir.
Now the topic what we are discussing, schema refinement. Now we are going to change this high level data. The schema you have to refine. Maybe sometimes we are going to remove, sometimes we are going to add, sometimes we are going to adjust. That is what exactly the refinement. Here, when whatever the database you are designed, here please remember third experiment also belongs to this topic. Means normalization. Means you are designed ER model and you are converted ER model to the relational model. Then after conversion of relational model, I told you you skip some pages because normalization. After that, you have started SQL queries. Here, before starting SQL queries, actually you need to do the refinement because whatever the tables were taken from the ER model, if that tables are not sufficient, that relations are not sufficient because of the redundancy. What are the problems are there? We will discuss. Here we need to refine the schema, means change the schema. That's what add or remove or modify the schema. Why should we modify? When should we modify? How should we modify? I will tell you. Don't worry. But the meaning of this topic is we are going to ultimately we are going to change the schema as per the requirement. Now understand the topic. The intention of the topic is understood, everyone. Why the schema refinement is required, I will tell you. First of all, the schema refinement means the main goal is we are going to change your table structure. The why table structure is need to change, how to change, I will tell you. First of all, understand this intention of this topic. Are you clear? All of you clear about the goal of this topic?
Yes, sir.
Yeah. Now, just I am going to read the instructions, simple or whatever I just told you. Schema refinement is intended to address and a refinement approach based on decomposition. Here, one more point also here we need to remember. Here already I told you just now, schema refinement is nothing but it is going to change the high level data. Here for this we need to use decomposition approach. Here, what is the meaning of decomposition? What is the English meaning of decomposition? Can you tell any one of you? Hello? What is the meaning of decomposition?
Breaking into parts.
Yeah, breaking, dividing. Yes. Here now this is the schema. Here because of some problem. What are the problems? I will tell you that. First of all, understand. Because of some problem, the schema refinement is required. Here we need to follow the decomposition mechanism and apply the schema refinement. Decomposition means we have to break this table into two tables or three tables. Here I have to take it article number, name and article number, name and what is this? Article number, name and GPI is one table and article number, department and age is or gender is another table. So like that, I am going to divide my tables into two tables. One is student table, another one is the grade table. The GPA, article number, GPA and age is one table. Article number, name and gender is another table. So like that, we can divide the table. That is what decomposition. Understand? All of you understood meaning of decomposition? How to decompose? What are the rules, regulations? I will tell you. First of all, understand the meaning. Are you clear? Why should we decompose? Also, we will discuss. When should we decompose? Why should we decompose? Where should we decompose? So all these things we will discuss one by one. First of all, understand the meaning of decomposition. Are of you clear this? Are of you clear this? Hello? Hello? Are you there? Yeah. Now we are going to refine the schema with help of decomposition. Clear? Clear? Right. Now, this redundant storage of information. Why this schema refinement is required? Here, redundant storage of information is the root cause of the problems. Here, when we are going to insert records, the first record, second record, third record, and fourth record. Maybe the hall ticket number you are given as a primary key, so that it never accepts the redundant data. But when you are inserting, maybe you will get GPA 2.4, 2.4, 2.3, and 2.4. So what happened? Redundant data has came 2.4 three times. The age also 23, 24, 23, and 23. Age also. And this type of redundancy of data are going to there in the low level data. To avoid such redundant information, we need to refine the schema with help of decomposition. Understand? All of you understood? So the data is same data we are maintaining more than one time. That is called redundancy. Anyway, we are given constraint, primary key constraint for only one column. We cannot give all the columns. Sometimes we can give unique key. Sometimes we can't give the unique key, some of the columns, so that there is a chance of redundant information. In same data, we have to insert, maintain more than one time. Here, such information is called as redundancy. Here we are going to avoid this redundancy compulsory because our database management system main agenda goal is to avoid the redundancy or to reduce the redundancy. Here, to avoiding of this redundancy, we need to do the schema refinement. The schema refinement will be done with help of decomposition of the relation. Means we need to divide the table into 2 or 3 tables as per the functional dependency. Functional dependency is a mechanism we will learn. So that is a mechanism, mathematical representation. Based on that, we will decompose. Now understand? All of you understand why why schema refinement is come? Because of the redundancy. So this schema refinement will be done based on the decomposition. Are you clear? All of you clear? Hello? All of you clear? I am not getting any voice.
Yes, sir.
Yeah, please respond. Right. Now, for this decomposition, can eliminate redundancy. Just now I told you, when you are decomposing, automatically it is going to eliminate the redundancy. How it is going to eliminate, I will show you, don't worry. It can lead to problems of its own and should be used with caution. 100%, whatever the problems are there for redundancy, we are going to eliminate redundancy with help of this decomposition. Okay. For this schema refinement, we need to apply decomposition. So this is what exactly the meaning of schema refinement. All of you clear about this? With schema refinement? All of you clear? Hello? All of you clear about schema refinement?
Clear, sir.
Now, I told you, when we want to perform schema refinement, you must be use decomposition. The decomposition is going to avoid the redundancy. Right. Now, because of this redundancy only, we are performing this schema refinement, correct? Because of this schema refinement, we are going to implement schema refinement because of the redundancy, correct? Yes or no?
Yes, sir.
Yeah. If you are not applying the schema refinement, nothing but decomposition, then what are the problems are there for redundancy? That we have to learn first. Why this schema refinement is required? Because to avoid the redundancy. Then what are the problems are there for redundancy? If you know the problems of redundancy, so that we can understand schema refinement importance. So that here problems caused by redundancy. What are the problems are there of this particular redundancy? And generally, redundancy is a method of storing the same information redundantly. Same data we are storing more than one time. More than once we are storing the data means we are maintaining the data more number of times. And this is what. When we are doing this, data we are maintaining more number of times. Basically four problems are going to occur. The first problem is redundant storage. That means same data we are storing these many times. Then we are storing same data 3 times means we are utilizing 3 times of memory for same data. So that the first problem is redundant storage. We are storing same data in a more storage locations, which we are wasting the memory location. Clear? You know this very well. Everyone knows this. Clear? Already we discussed earlier, I think. Hello? Hello? I am not getting any response.
Clear, sir.
Yeah, please respond. Now, second one is the update anomalies. Anomalies is nothing but a problem. Don't think anomalies is something. Anomalies is a problem. Update anomalies means when I wanted to update. For example, I wanted to update this GPA 2.4 to 2.5. Then what happened when I am don't consider this article number directly? I want to update wherever 2.4. Now I want to update 2.5. If I do that, what happened? All remaining also it is going to update. Understand? I want to update only this particular field, but I will not consider hall ticket number primary key. Directly I want to update wherever 2.4 is there for GPA column 2.5. Then automatically remaining all the columns are going to update 2.5 with 2.4. So this is what update anomaly. Are you clear? Are you clear? Are you clear?
Yes, sir.
Now, insertion anomalies. It may not be possible to store certain information unless some other unrelated information stored as well. Means that when I am inserting a new record along with the GPA is 2.4. Here, if you don't consider all ticket number, we cannot insert same again 2.4 because the data already it is existed. Means we have to consider remaining fields also, so that only the new record is going to insert. If you want to insert only hall ticket number, no need to consider anything. Directly you can insert hall ticket number because this is the primary key. It will be accepted uniquely. This is the problem for insertion anomaly. We are coming to the last deletion anomaly. Now I want to delete one record which the GPA contains 2.4. If I want to delete this 2.4 record, automatically then all these three records are going to be deleted because same data is there. If I am not considering alternate number, just I want to delete directly. Delete students where GPA equal 2.4. Then automatically the records which is having GPA 2.4, all the records are going to delete. Actually, my intention is I want to delete only particular record, but it is going to delete all the GPA 2.4 records. This is what exactly the deletion anomaly. That means when you want to perform any operation on this redundant data, it is not consistent. It is an inconsistent operation will be performed. You know what is the meaning of inconsistent? Here, what I want to perform, but it never performs same. It is going to affect to others also, others records also. So that is what exactly inconsistency is going to happen. Understand? Problems. Okay, problems of redundancy, redundant storage, update anomalies, insertion anomalies, and deletion anomalies. Are you clear? Are you clear? Hello? All of you clear? Time is running quickly.
Clear, sir.
Please, very important. Right. Now, one example, please consider this example. Please, even if you want to write also, please note it down, this example. It will be help a lot for your future examples or future discussion on this unit, normal forms. This will be help a lot. Please try to note it down, everyone. Your serial SSN is nothing but a serial number, okay, student serial number, name, location, MOT, rating, hourly wages, hourly work. All of you please note it down. This example is very important. Done? All of you done? You can take any name, not a problem. These values are important for this example. You can take this SSN and name, whatever the name, whatever the serial number, you can take it. It is not an issue. These values, this is very important for this example. Okay. Yes. You can write any name or any article number. Your article numbers also you can write it. Not a problem. Because it is a unique, right? These are unique. Clear? Done? All of you taken this? Hello? All of you taken this? Right. Just I am continuing. Now, when we are observing this location, here 35 is having 3 times. Correct? Yes or no? Yes or no?
Yes, sir.
Now this 8 is having 3 times and 5 is having 2 times in this rating, correct?
Yes, sir.
Is it right? Now the hourly wages is having 2 times, sorry, 3 times, and the 7 hourly wages is having 2 times, correct? Yes or no?
Yes, sir.
Now hours worked 40 is having 2 times, 30 is having 2 times, 32 is unique, okay, like this. These are the numbers are there for this given table, correct? Means redundant data is there. 8 times, 3 times, 35 to 3 times, 10 3 times, 7 2 times, 32 times, what like that. Some redundant data is means more than one time it is there. Yes or no? This is our observation from this example. Hourly employees relation. Clear?
Yes, sir.
Yeah. Now, now here what is the redundancy problem in the given this table? The first one is the redundancy storage. Means same value you are storing. Anyway, you are assigning memory, right? So that here if it is integer, then 3 integer same value you are storing means memory is wasting. The first problem is done. Correct? Yes or no? Hello? Yes or
Yes, sir.
no? The second one is update anomalies. Here, when we are going to update hourly wages in the first tuple, it will be updated without making a similar changes in the same tuple. Compulsory, we need to follow this. Means, if you are going to observe any tuple you want to update or any tuple you want to even you insert, you must be followed. Because if you observe rating 8, who is having rating 8, the hourly wages is 10. Check this. Who is having rating 5, the hourly wages is 7. Yes or no? Hello? Are you observed this?
Yes, sir.
Yeah. Now, when you want to update or when you want to insert and when you want to delete, compulsory we need to follow this mechanism. Otherwise, your insertion is wrong, otherwise, your deletion is wrong. Is it right or wrong? Otherwise, your insertion is going to anomaly, your deletion also anomaly. Because if you want to delete 8, automatically what happened? These 2 records are going to delete. If you want to update this 8, these 3 records are going to update. Yeah, sorry for the interruption. Suddenly, internet is maybe the off and again it came back. Okay, is it audible?
Yes, sir.
what we are discussing. Yeah. Now you know that these things will be happen when you are going to perform this operation, updation, insertion, deletion. Then automatically the things are going to happen. Are you clear? Are you clear this? Hello? Are you clear this?
Yes,
Yes,
sir.
sir.
Yeah. Now, one more point also I can add here. When you are using null values, when you are using here some null values, hours, wages, or some rating, wherever you want to use some null values, so the null values never affect anything. Okay, and redundant storage or any anomalies are not going to work. So don't think about the null values. If you are having null values, we cannot consider, we cannot decide, we cannot take the decision because null means not defined. There is no memory location, so that it never affect memory. There is no chance of the updation problem. There is no chance of the insertion problem. There is no chance of the deletion problem. That's why here maximum cases we never consider null. If any null value is there, we cannot have any problem with any redundancy because null means you don't feel, sir, all nulls are there so that the data is redundant. No, here null means there is no memory. If there is no memory means there is no meaning of the value, so that there is no chance of the redundancy. Are you clear? Are you clear? Hello? Are you clear? Hello? I'm not getting any voice from your side. Are you clear?
Yes, sir.
Right.
Yes, sir.
Right. So that's why we never consider null value to not provide any general solution for problem of redundancy because we don't have any redundancy problem with null value. Now coming to the next topic, decomposition. Here, how to decompose a relation. I told you when you want to perform schema refinement, you must be apply decomposition. Here now we are observed this table is having redundancy. Yes or no? This table is having redundancy or not? Time is running, please. This table is having redundancy or not?
It's having, sir.
Yeah. So that because of this redundancy, we are having these anomaly problems. Yes or no? That is redundant storage, update anomalies, insertion anomalies, deletion anomalies. Yes or no?
Yes, sir.
Yes, so that what should we do if it is having these anomalies because of the redundancy? What should we do? We need to apply schema refinement. Schema refinement in the form of schema refinement in the form of
Decomposition.
decomposition. Now we need to apply the decomposition. Yes, here already we know the decomposition is nothing but we are going to divide the table into some parts. Here, when you want to decompose the table, you need to find the functional dependencies, FDN. Sometimes it is called as FD, means functional dependencies. Here, what is the meaning of functional dependency? Means one column is depending on another column. One column is depending on one attribute in a table. One attribute is depending on other attribute, that is called as functional dependencies. Are you clear? Are you clear? One attribute in a table depending on another attribute in the same table. So that relation is called as functional dependency. Are you clear?
Yes, sir.
Here I will show you. Here, what is the functional dependency here? In this table, what is the functional dependency? Tell me. In this table, what is the functional dependency?
Hourly wages.
Hourly wages, hourly wages.
Depending on rating.
Yeah, depending on rating. Yes, exactly. Yeah, that's why you can write like this. Rating determines hourly wages. Means this hourly wages always depending on the rating. This is called functional dependency. Here we will discuss in the next class. Here, what is the functional dependency, how to define, what are the categories, formulas we will learn. The basic information, how to decompose I am giving here. Now, we are identified functional dependency here. Initiatively, redundancy arises when a relation schema forces an association between attributes that is not natural. Functional dependencies can be used to identify such situations and suggest refinement to the schema. The essential idea is that many problems arising from the redundancy can be addressed by replacing relation with a collection of similar relations. That is a decomposition of a relation schema or consisting replacing the relation schema by two relation schemas that each contain a subset of the attribute. This is very important. Each you are dividing the table, after dividing that relation, each contain a subset of the attributes of R and together includes the attributes of R. Means if you are having table, here we are identified functional dependencies. Here one attribute must be common in the after decomposition of two tables, one attribute must be common in the first table and second table. If that is a minimum rule. Here compulsory we need to do it. That is the meaning. Now, after identification of functional dependencies of your table, now we need to decompose the table. Then how to decompose? The two tables here, hourly employee table and wages table have taken to decompose because here rating and hourly wages is depending on rating, correct? Yes or no? Yes or no?
Yes,
Hello?
sir.
Yes, sir.
So that here remaining attribute I have taken into hourly employee except rating and hourly wages. Please remember. You are identified functional dependencies. So that is hourly wages is depending on rating. Here, except that we need to take remaining elements, remaining attributes into first table, which is hourly wages, SSN, name, LOT, hourly worked. Here, why rating is taken? Already I told you, when you are going to decompose a table into two tables, one attribute must be a common in the both the table. So that is rating is here, rating is here. Why it is common? When you want to join these two tables, you will get the all the tuples. Here, one common attribute is there, then only you can use the join operation. Understand? Understand?
Yes, sir.
Yeah, so that here you need to write the table as it is with hourly employee, SSN, name, LOT, rating, hourly worker. Now as it is. Now coming to wages. Here wages, how many types of wages are there here? Tell me, how many categories of wages are there? Tell me. Means how many types of rating is there here?
Two.
Only two categories. If it is 8, hourly wage is 10. If it is 5, hourly wage is 7. So that we have two tuples only here. Understand? Understand?
Yes, sir.
When you want to know hourly wage of this employee, for example, this employee hourly wage you want to know. Means we are going to join with rating with these two tables. Then automatically, if it is a rating is 8, automatically it is going to show 10. Understand? Here what happened? For every time you have to return rating this 3 times 8 and 2 times 5 and wage hourly wage also 3 times 10, 2 times 7. Here instead of this is very simple table. If you take 1,000 records or million records, you can understand how much memory you are wasting. For simplicity, I have taken this very simple table. Now we have only two records we have using, but otherwise you need to use how many records? One, two, three, four, five. 5 times 5 records we need to do. But here only 2 times. Now it is reducing, right? To tuples, it is reducing means here more memory it is reducing. Understand? Are you understood? Hello? 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 All of you understood this
Yes, sir.
decomposition? All of you understood this decomposition? Hello?
Yes, sir, understood.
Yeah. One point also you remember here, we can avoid the redundancy using this database management system, but you cannot completely remove the redundancy because here this table contains rating three times. This table contains LOT three times and hourly wages also this time. Here, without functional dependency, we cannot decompose the table and we cannot remove the redundancy. Just we have to reduce the redundancy. Don't think 100% we are going to remove the redundancy in the data tables. It is not possible. Only if we are going to find the functional dependency here in the table, based on the functional dependency, we need to decompose and we are going to reduce the redundancy of the database. Okay, don't expect 100% we are going to remove the redundancy. Are you clear? Without functional dependency, we cannot decompose. Sir, we have different types of functional dependency mechanisms. We will discuss in the next session. Don't worry. But uh, uh, this way, we need to find the functional dependency. Means one attribute is depending on another attribute. Are you clear this? Are you clear this? Hello?
Yes, sir.
Yeah, only small topic is there. After this, we will wind up the class. Problems related to decomposition. Yes, here I decomposed because of the redundancy. I applied schema refinement. Schema refinement is told to decompose the relation. Here I identified functional dependency in the relation and I decomposed my relation and I reduced my redundancy. Okay, good. Up to this, good. But when I decompose the given relation into two relations, table 1 and relation 1 or relation 2, or table 1, table 2, I decompose it. But after decomposition, is there any problem? Because here, if you are going to directly decomposition without analysis of the problems, so sometimes we are going to lose the data. So that we need to analyze when we are going to decompose your table, we need to analyze is there any data is going to loss or any problem is going to happen. That is very important. With only we are identified functional dependencies and directly we are decomposed your table, you are not followed any mechanism, then automatically data is going to lose. Here, if it is a banking transaction or financial application, if some one record is going to lose, there you know some crores of money is going to lose. Yes or no? So that we need to analyze is there any problem of the decomposition of the table. After decomposition, is there any problems we are going to face? So this is very important topic. That is what I have to do this. Clear? Understand? Understand? Decomposition problems. Why decomposition? We need to verify the problems before decomposition of the table. Clear this? Hello? Hello? I need response.
Yes, sir.
Yeah. Now for this decomposition, when I want to decompose a table, so before decomposition, we need to check two important points. I told you two important questions you can ask yourself when you are going to decompose a table. You can ask two following two questions to yourself, and if you get the solution, and go for the decomposition. If you are not getting the solution, you are feeling a problem, don't go for the decomposition. You can make it, you maintain redundant data, not a problem. So because if you are losing the data because of the decomposition, your lot of information is going to lose. Finance, if it is a financial application, someone is going to lose millions of money. So that before decomposition, you can ask two questions yourself. The first question is, do we need to decompose a relation? So do we need to decompose a relation? It contains, to help with a first question, several normal forms have been proposed for the relation. Here we have five normal form: first normal form, second normal form, third normal form, BCNF, and fourth normal form. Here that relation is suitable to any one of the normal form or not. That is what? Do we need to decompose a relation? Meaning is if that particular relation is suitable to any normal form or not. You need to check. If a relation schema is one of these normal forms, we know that certain kinds of problem cannot arise. If that relation, whatever the relation you want to decompose, this relation is having the first normal form related to first normal form, second normal form, third normal form, fourth normal or BCNF. Whatever the normal forms are there, it is suitable to any one of the normal form. Then you can apply the decomposition. There is no chance of any problem. Any problem. Clear? Clear? Hello? Clear this? Hello?
Yes, sir.
Right. Now, after identification of the normal form, suitable, how to identification of suitable normal form, I will tell you, don't worry about it. First of all, I am giving the introduction. So how to identify that normal form, I will tell you what is the normal form, and how to identify normal form, I will tell you that. Considering the normal form of a given relation schema can be help us to decide whether or not decompose it further. Yes, if you are identified the normal form, then automatically that normal form will tell how to decompose the table. Don't worry about it. If you decide that a relation schema must be decomposed and further we must choose a particular decomposer. Simple. Here means here the first question is what? Do we need to decompose a relation? Means you want to decompose a relation. If you want to decompose a relation, then you need to find that relation is suitable to which normal form. If you are going to identify that relation is suitable for particular normal form, the normal form itself it is going to tell how to decompose the relation. So once we are going to use the normal form for decomposition, there is no further problems, further sequences for the decomposition. Are you clear about this first question? Are you clear about this first question? Can you ask yourself? That is what very important is. Are you clear this? Hello? Time is running. Is this clear?
Yes, sir.
Right. The second question is, what problems does a given decomposition cause? Here, when you are going to decompose, is there any problems? We will get. Here, means the first question is that is suitable for decomposition or not. Second question is, here, after decomposition, shall we any problems we will get? Here there is a chance of two problems you need to analyze. The first one is the lossless join. The second one is the dependency preservation. Remember this lossless, a very important point. This topic is very important. Please remember. If you are having any problem, you can ask. The lossless join and dependency preservation. What is this? So just now we decomposed, right? We are decomposed the relation, right? Hello? We are decomposed the relation. Yes or no? Hello? The time is very less. I have to finish it. Please respond. This relation we decomposed or not?
Yes, sir.
Yeah. After decomposition, now after decomposition, you need to check. Before decomposition, you need to check that relation is suitable for which normal form. That is done. Now I have decomposed already. Now after decomposition, you need to check two things. One is lossless join. Another one is the dependency preservation. Here, what is the meaning of dependency preservation? Dependency preservation means the same column name must be there in the two tables. That is a dependency preservation. Means this rating hourly wages table is depending on hourly employee table. Wages table is depending on hourly employee table because same common column is there in the hourly employee table and wages table. Correct? So that is what it is, a dependency preservation. Are you clear? You need to check that dependency preservation is there or not after decomposition. Clear?
Yes, sir.
The second one is the lossless join. Means when you are going to join these two tables, means hourly employee and wages table, if you are going to join, you will get the original table without any loss of data. So that is what lossless join. That means here if you want to know the hourly wage of this particular guy, then you join it, automatically you will get the 10. If you go with this 8, again you will get 10. Again, if we are going to get, again this is 5, then you will get 7. Means here if you are going to join these two tables, there is no data loss. Yes or no? If you are going to join these two tables after decomposition, when you are going to join these two tables, then there is no data loss. It will be show like original data, original table data. Yes or no? After joining.
Yes, sir.
Yeah. So this is a lossless join. Means here the first question is what? Here before decomposition, we need to check that is suitable for which normal form. You need to identify. Here after identification of the normal form, you apply the decomposition. The second question is here after decomposition, you need to check the functional dependency preservation as well as lossless join. If it is a redundancy preservation is there, dependency preservation is there, the lossless join automatically it will become. So these are the 2 points you must be remember before we are going to apply the decomposition. Are you clear now? Are you clear?
Yes, sir.
This you do it, this second point you do it after decomposition. This first point you do it before the decomposition. Understand?
Yes, sir.
Yeah. The next class is functional dependencies. Here already I told you. Here when you want to decompose, you need to find the functional dependencies in the relation. The functional dependency is going to play a vital role. If you are going to understand functional dependencies, then directly you can understand normal forms also. Once we are going to finish up functional dependencies, we will start the normal forms. Is it okay, everyone? Clear? All of you clear this? Hello?
Yes.